Hello everyone, my name is Nick Sun. I am a solutions architect at AWS. I'm based in the beautiful city Melbourne, Australia. Firstly, thank you for joining me today, and we will have a chat through getting started with serverless computing using AWS Lambda. So in today's session, we will start with talking about some serverless concepts, then we focus on the AWS Lambda service itself. I hope you will gain some knowledge around different AWS services involved and the tooling you will require to draft your serverless application. So firstly, let's have a look at the serverless concept. So firstly, there's no server to provision or manage as it sounds like. So your hands are off from the OS patching, package upgrading, etc. The serverless applications scale with usage. So as user requests coming in and amount of traffic grows, with more data entering your applications, the core unit to scale shifts from servers to functions. And one of the highlights of serverless approach is that you do not pay for the idle time. Applications running on top of these services will have built-in high availability and disaster recovery. All the serverless services we speak today are sitting in the regional level, and they automatically expand across multiple availability zones. The core component for most serverless workloads is a function as a service, and it's AWS Lambda. So to invoke a Lambda function to run, there are different sources of events, such as a state change to a data storage, a request sent through to the endpoint of a service, or a change to a resource within your AWS environment. And once the function is running, it can do a lot of things, such as consuming other services, processing business logic, just like you run applications on top of a server or from inside of a container. The entry point for a Lambda function is called handler. So this is similar to the concept as main function from C program. So the major parameters passed to the handler function include an event object, which contains information such as the source of the event plus the payload itself, and a context object, which contains the information of runtime of the function, such as the identifier of the request or the CloudWatch log group used by this Lambda invocation. The pricing model for Lambda is purely pay-as-you-go. The cost is based on top of 100 milliseconds increments of duration of a running function with the amount of memory allocated to the function. The AWS free tier covers 1 million requests and up to 3.2 million seconds of compute for all the customers. You can have this free tier even after 12 months. And again, we never need to pay for the idle time. The code for a Lambda function could be written in Node, Python, Java, C#, or Go, with all dependencies be included in the artifact. The resource model is very straightforward. You only need to allocate appropriate amount of memory to your function with values from 128 megabytes to 3 gigabytes. Keep in mind, when tuning Lambda memory allocation, more memory means more CPU power, and usually comes with less execution time. So more memory, sometimes it doesn't mean that higher cost besides the execution time being shortened. Lambda could be either synchronously or asynchronously invoked, depending on the source of the event. We will describe this part later in this session. And security is always the highest priority in AWS. You can securely grant your function accessibility to resources from AWS services or within your VPC. Let's have a look at how this access control is operated. So with Lambda permissions model, we're talking about two types of policies here. So execution policies. So this part, it allows your function to assume an IAM role with a specific policy. So the policy defines which downstream service your function could consume or any resource your function could access from anywhere. Also, there is a function policy. So this part, it defines which source of the event could invoke this Lambda function. For example, you could define that only the request from API gateway could invoke your Lambda function and nothing else. And then when we draft the code for the function, you could leverage text editor or your preferred IDEs such as like Eclipse or Visual Studio with the plugins, which can help you to deploy your functions, or you can use Cloud9, which is a web-based IDE from AWS. I will show you some tools later in this session to help you quickly start a skeleton for your serverless application. There are also tools from AWS platform for monitoring and logging how your function works, such as CloudWatch log groups, AWS X-Ray, etc. With Lambda, we include some libraries within the Lambda service itself, such as the AWS SDKs. But sometimes you might see maybe there's a version mismatch. So for that reason, we recommend self-containing your dependencies in your package as much as possible. A Lambda function at runtime should be stateless. Even if you have some temporary space, you should use external storage facility to store states such as data for user sessions, etc. A Lambda function could be invoked by a few different ways. So if a Lambda function is backing up APIs from API gateway, the invocation will be synchronous. So the function must return the result as response sent back to the caller. And for those functions triggered by events such as S3 bucket operations or SNS, the invocation will be asynchronous. So in this situation, the function does not have to return the result back to the source of the event. So for the data stream services such as DynamoDB streams or Kinesis, Lambda service will schedule an invocation to regularly pull the source of the data, such as a partition of a DynamoDB table or a shard of a Kinesis data stream. Around mid this year, we launched the feature for Lambda to be triggered by SQS. So when the message arrives at SQS queue, a Lambda function will be invoked and then pull the queue, processes the message, then deletes the message from the queue. So this feature allows Lambda to be working with the queuing service provided by AWS platform. And there are all different use cases our customers are making use of Lambda functions at the moment, from web applications to processing IoT workloads, from MapReduce functions to like a backend of a chatbot. So for example, if you have an Amazon Echo device at home, you must be familiar with the Alexa skills. You can actually create a Lambda function as the backend for your Alexa skill, and then you can use that function to interact with your data besides your verbal interaction with your Echo device. And one important area is the IT automation. So customers can make use of Lambda functions to perform tasks such as auto response to an incident, infrastructure management, etc. A great example here is to use Lambda functions scheduled by CloudWatch scheduled event to start or stop non-production environment in or outside of business hours, which can bring great cost savings to the organization. So since we have mentioned web application, which is one of the common use cases here, I would like to give Amazon API Gateway a quick introduction. API Gateway is a managed service as a RESTful API proxy in front of your backend services. API Gateway supports WAF and has DDoS protection and can throttle traffic to protect the resource at your backend. It also provides different options to authorize different types of users from access control perspective. In the real-world scenario, API Gateway behaves as the proxy for a lot of traffic coming through to your backend. Your backend could be Lambda functions, it could be applications running on top of the EC2 instance, it could be some resources from your VPC or other AWS services such as S3 or Kinesis. So to implement the serverless approach as a completed workload in the cloud, we recommend you to use CloudFormation to achieve what we call the infrastructure as code. So for serverless application, we have a special tool for developers to mock up environments easily and quickly. So as serverless applications become more complicated with hundreds or even potentially thousands of Lambda functions, there is the need to provide a more effective way to model our applications, and that's why we came out with Serverless Application Model, or SAM. So SAM is built on top of CloudFormation, so any third-party tool that supports CloudFormation will inherently work with SAM. It supports a lot of great CloudFormation features, like parameters and those built-in functions. Then you can combine those serverless resources and notations with the traditional CloudFormation resource and notations, so you have the flexibility over there. Let's have a brief look at how a SAM template is drafted as an example. Here we see that in this template, it needs to be transformed to a CloudFormation template. We will demonstrate this part later. Then we can see the function definition plus the definition for its source of event. In this case, an API is needed from API Gateway. Also, we could leverage simple table to have a DynamoDB table created with 5 read capacity units and 5 write capacity units. At deployment, this SAM template will be deployed as a CloudFormation stack, just like other CloudFormation templates. And you can replicate this stack from different regions, different accounts, for different purposes. So with SAM template, there's also a tool called SamCLI, and previously known as SAM Local. So this tool can help you to develop and test mocked events, test your Lambda functions with a local copy of API gateway running as a container on your laptop. So it supports hot reloading, so you can change your code on the fly and test them locally. SamCLI can be used with different commands. For example, we can use init to initialize a serverless application as a code skeleton, and we can use package or deploy to transform SAM template, then deploy it with CloudFormation. Now let's have a look at how SamCLI works in a demo. So here I would like to demonstrate how SAM and SamCLI working in real action. So in this demo, I'm going to run my environment inside AWS Cloud9, but you can also do this from your local environment, such as your laptop. Firstly, I've already got SAM installed in this environment. If you don't have, please install Python environment and use pip to install the SamCLI. So here I want to check, firstly, the version of my SamCLI, and it's 0.6.1, which is the latest version. Great. So if I type sam-help, I can see a whole bunch of different options, such as the logs, deploy, package, init. So maybe we can use this one to initialize a serverless application with something. So I'll type sam init. But I don't know what to type next, so I can type --help again. So we have quite a few options here. We can use just initialize a Python 3.6 runtime. We can also use different templates from different GitHub repositories. We can also use zip file with a template within. I would like to show you actually this part, which is we can make use of what we call a cookie cutter, which is a framework, which can help us to quickly spawn up an environment with all the required components out of box. So let me just copy that and paste this command. So let's say sam init location from this place. Then I've typed enter. Because I've already done this before, so it just asks me if it needs to re-download the template again. So I just type yes. Okay, so now I need to give my project a name. So I just give it like a sam-cookie. Maybe a short description, like just say sam cookie project. Include API gateway? Yep, why not? X-ray? Yep, let's see how it works. Safe deployment, I'll give this option a no. The safe deployment means it will leverage code deploy to achieve a canary deployment that is more reliable, but it takes a longer time to deploy. Experiment make? Nope, so as default. Now, what we have is a folder called sam-cookie. So let's get inside and have a look what's inside there. Let me clear my screen. So firstly, there is a pip file. So I can use maybe the pip environment, pip env, to set up my environment to be aligned with what's defined in the pip file. So here we can see that it requires Python 3.6. And together, we have a file called readme.md. So this file is actually an instruction of how we can make use of this code base. And let me see a user-friendly version of that. So we have the SamCookie project with the description. We have requirements, different commands to help us do the testing, to do the packaging, local development. I'll show you later. And then we can deploy that. So let's run things one after the other. So firstly, let me make sure my environment is aligned. So now I have Python 3.6. If I type Python I have 3.6.5, great. So the next, as instructed here, I will need to maybe install the dependencies. But actually, if we look at the dependencies, there are only two things in there. Only the Boto3, which is the SDK for Python, and the X-Ray SDK. We've already told the project that we want to have X-Ray embedded. And together with these files, we do have a file called template.yaml. So this is actually, I'll just close this README for now. So this file is the SAM template itself. So as we can see, it needs to be transformed. And the next part is we are defining a function here. The function is called, so the handler is app.lambda handler, and the file should be located from this UI, from this URI. So if we go back to the instruction, there is instruction telling us that we should have the application file to be copied to the build. So actually, the build folder under the first function is where we're going to package our application and deploy to AWS Lambda. So what we're going to do here is, firstly, let's install all the dependencies. So let me copy this command. So in this case, I'm going to install the Boto3 and the X-Ray SDK into the folder here. So I have the build folder, I have all the dependencies, and everything's been installed. So the next thing, I'm going to copy my function file into that location. So my function file is like this. So let me show you the code inside. So from the template, the handler is called app.lambda handler. So the app is this file, and we get in there, we should see Lambda handler. So that's the entry point of this function. So this function actually does nothing but just to return a message. The message was saying, hello world. So these conditions are actually to detect whether this function is running in the local or in a AWS cloud environment. So before we're doing something else, let's try some local test stuff. So let me clear my terminal. So if I do, let's say, sam local start API, let's see what we can run from here. So basically, I have a Docker container actually running at port 3000 in my local environment. So let's check what it does. Let me open a new terminal. See if I curl this location, port 3000. So it says it doesn't work as expected. So what are we missing here? Let's go back to the template. We found that, oh, the API path should follow this pattern. So let's do this one. Let's do first. So it could be any arguments. Let's just put hello. Here we go. We see the hello world returned from the local running function. As you can see that I'm running all of this in my local environment. We could do this even without internet connection. And one thing I would like to try here is I would like to modify my code. Maybe I can change it from hello world to hello lambda. Let's save it. And I'm not going to rerun my SamCLI, so I'll just keep it running. But I just try to reload what we can get from this URL. So as you can see, the change has been reflected. And you can do all of this in your local environment, which is great. So the next part is that we want to deploy this to the AWS cloud. Then let me reopen my README file, see how we can deploy this. So to deploy, firstly, we need an S3 bucket. Actually, I've already got my bucket created. So we need to run this command. So I'm going to run this command, and the S3 bucket name is my own bucket. oh, sorry, I must be in that SAM cookie folder. Then I run this again. Now, my template has been packaged, so I can now deploy that. So what I'm going to do next is I can run this command to deploy my package. So enter. So let's go back to AWS console, and what we can see from CloudFormation is that we've got a stack under creation. So let's give this one a few moments. So what we've seen so far is we can make use of SamTemplate to define all the resources we need, such as the function itself, the source of the event. In this case, it's an API gateway API, and then we can use this different CloudFormation command to generate the template for CloudFormation to launch this stack in the cloud. So this can help us to seamlessly deploy our package from our local to a specific environment. Okay, now the stack is done. So what I'm going to do here is so it's completed. How about if we can access this application from somewhere? Let me check this README file again. I can use this command to describe the details of the stack we've created. As you can see, we have a URL being generated for us. So let's copy that, and let me paste it here. Oh, it says, let me zoom in. It says something was wrong. Because we've already got X-ray enabled, let's maybe check X-ray to see if there's anything we can capture from there. So let me check the trace. Okay, I can see there's a trace list. Let me zoom it out a little bit. So let me open this one, and I can see something goes wrong. And it can tell me, actually X-ray can tell me which line of the code brings us the error. So I can see that this is line 106. So maybe let's get back to our code. Our code is here, so 106. So this line is telling us an error. And because I've already know this code base, so I know that if we want to use X-ray recorder, we need to capture something first. So this line actually has been commented. So let me uncomment this line and save it. So let's test if my local function is still working. Yep, it's still working. Hello Lambda is still there. So what do we do next is I'm going to redeploy my function. So I'm going to package it again. Then we're going to deploy that. So in this case, because the CloudFormation stack is already existed, so what we're doing now is actually it will create a change set, and then the stack will get updated. Let's give it a few moments. Now it's done. So if we refresh here, yep, it's update complete. So let's refresh this page to see if we can get things fixed. Awesome, we have the Hello Lambda there. So let's go back to X-ray. Let's get back to the trace. Let's refresh it again. This is our latest invocation. We can see that everything's green, and you can see the details. And I will describe X-ray and CloudWatch logging from the monitoring and logging in the next few slides. So far, we have seen that how we can initiate a function, draft our code, then deploy it. However, we must know what's going on besides our functions at running, especially when something goes wrong. We need to know where and why. From monitoring perspective, you can leverage different metrics from CloudWatch for Lambda and API Gateway if it's used. So you can create alarms from this matrix if something unexpected happens and you would like to know about it. Or even better, you can create some auto response triggered by these alarms to deal with the issue in an automated way. While we debug or troubleshooting our Lambda functions, AWS Lambda leverages Amazon CloudWatch log group to automatically emit metrics and logs for all invocations of your function. One thing you can do here is to create your custom matrix from a log group by applying different filters, and you can target specific messages from the log. You can also stream the log to other services like maybe Elasticsearch or even S3. Then you could use Kibana for Elasticsearch or Athena with QuickSight for S3 to visualize this logging data. With all the different metrics, you can also mock up a dashboard from CloudWatch for you and the team to have an overview of the status of your serverless application. Actually, for tracing the event source that invoke your Lambda function or for tracing the downstream calls that your function made, AWS X-Ray could provide a deeper vision into your Lambda functions. You can enable it by ticking a checkbox in the function configuration. X-Ray also provides airport delay map with information such as the amount of delay, failure, and it also provides us the visibility to see the data such as the average execution time. Here is a quick example of what produced by X-Ray for a Lambda function. You can see that the entire duration of your Lambda function executing from the start to the finish. And the lower part in this diagram is specific to your Lambda function. So here you start with initialization phase, then the handler function, and then the rest of any downstream calls. In this example, it was S3. So to help you to get started learning about the code, we have a bunch of blueprints where you could see how a typical scenario has been implemented as Lambda function. For example, you can learn how to process event triggered by an object being created in S3. And there's also another place called Serverless Application Repository, where you can find applications for different use cases made by other developers from the community. So to conclude everything we talked today, you can find the relevant information from aws.amazon.com/serverless. So you can find things like documentations, links to different tools, tutorials, other information, almost every aspect you need to know when you create your serverless application. At last, thank you for joining me today. I hope this session is informative. Please feel free to reach me on LinkedIn. Thank you and enjoy the rest of the day.